Hey everybody, Jason here with AV Pro Edge. Happy Monday. I hope everybody had a great, refreshing weekend. Happy Father's Day to all the fathers out there. It is Monday, which means I am with Anthony Grimani. So Anthony, welcome to the webinar today. We are continuing our AV Pro Audio Expert Series, and today is going to be a very interesting topic, one that goes back to the early days of my own enthusiasm when it comes to AV. And that's really, what are we looking for when we're shopping for speakers? It's not all about the specs, as we know and we'll talk about today. I remember when I was first looking at speakers and stereos as a young kid and really starting to learn about this stuff, it used to always be about how many watts the speaker was and how big the magnet was and things like that. When we were kids, those were the important things. But as you start to formally learn about speakers and stuff, you quickly find out that it's not all about the specs. So we wanted to spend about an hour with everybody today talking about speaker specs and picking out speakers and what do all these specs actually mean. Now, Anthony, you being not only a theater designer, but speaker designer, this is right up your alley. So I'm really, really happy to spend the time with you today. So thank you so much for being here.
Fantastic, Jason. That's a great intro. Actually, in the end, it can be just about the specs if you want, but the specs list is long and you got to read through it. Yes, in the end, it's got to sound good. And kind of like you, when I was a kid, this is really going back years and years and years ago. I was actually going out shopping some weekend with my dad. I must have been 10 or 12 years old or whatever, and we walked up to the the hi-fi part of this one big department store, and this is going back far in my memory. And I remember, I can't tell you what brand it was, but pasted right on the front was a print of its frequency response.
Oh yeah.
And I actually asked my dad, like, what is that? It would, what? And it's like, whoa, son, that's a frequency response of the speaker. That's really important. That's good.
Anthony, was your dad also into audio video like you are, or are you first gen, or what's the story there?
Yeah, so my dad was actually an electrical engineer. Taught engineering, electrical engineering at the university in Melbourne, Australia. Interestingly enough.
Very cool.
Yeah, we would go out shopping. Circuit City didn't exist back then, but I'm just a little bit older.
Mm-hmm.
And I was telling the story that I just saw this frequency response, and he explained that to me. Well, that is still important. But then I think since then, through the work of a lot of people, and I will credit Dr. Floyd Toole again and again and again for some excellent qualification of what really does matter. We've all learned a lot more about what I would say objectively makes a good speaker. Objectively meaning something that you can look at on a piece of paper, documentation on a screen that's going to tell you, hey, this thing's going to work well for my application. But specs do matter. They've just gotten a whole lot more complicated than they used to be. So
we didn't lose you, did we?
Without further ado, like they say, let's get this thing started. Because we've already, I don't know. Yeah, let me know if you don't hear me. Okay.
Yeah, definitely.
It seems like everything's fine here, but
sure thing.
All right. So course overview. So the course here is intended to guide speaker selection decisions. That's ultimately what it's about. I'm not here to just to talk in theoretical values and stuff, but just help you figure out what you need in deciding what you're going to use in a home cinema. Actually, everything I'm talking about also applies to 2-channel stereo. This is not specific to home cinema. Home cinema brings a whole bunch of additional requirements to it, but everything I'm saying here just applies to good sound at a loudspeaker. So I'm going to spend a bunch of time talking about the importance of what's called sound power. I'm going to spend a little bit of time on sound pressure level, but we already had this session before that I'm going to refer you back to. It was called How Loud is Loud Enough? So I'm going to skim over some of that stuff. We're going to talk about coverage. Coverage being your audience is a certain size from left to right and front to back, and how can you tell from looking at the speaker specs whether you're going to be able to cover everybody sitting there. And then we're going to talk about other stuff, including distortion, impedance, etc. So a bit about me. My name's Anthony Grimani. I have 3 companies: Grimani Systems, PMI Engineering, and Dimension 4 Acoustics. Grimani Systems makes some really cool speakers. that are essentially designed to meet the requirements I'm going to talk about here, again, which are not just our opinion, but the current state of the art from the speaker industry of what makes a good speaker. PMI Engineering designs high-end listening environments, mainly for home cinemas, but also recording studios, post-production facilities, performance halls, and anywhere where there's essentially microphones and or speakers and or screens. And then the Dimension 4 Acoustics Group makes and sells acoustical panels and acoustical materials for all kinds of applications. I have a degree in electrical engineering. I spent 5 years at Dolby, 10 years at Lucasfilm THX, and then 20 years ago, I left all of that to start my own company and have the freedom to work a lot. So I've been doing this for 35 years, and it's I've had a lot of fun. I made the top 50 industry influencer mention from Custom Retail and the top 20 industry personality from CE Pro magazine. Work that we have done for integrators worldwide have won many CDI awards, and I made the top CDI instructor, and along the way invented the Surround EX thing that was launched with the Star Wars Phantom Menace movie. Yikes, back in about 2000. A little while ago, 20 years ago. Wow.
It's funny because I remember I mean, gosh, in 2000 I was 19, so I remember when that movie came out and seeing that surround format and being like, holy crap, a new sound format, this is awesome. And then in the meanwhile, here we are, 20 years later, I'm chit-chatting with you, so it's really, really cool. That always blows my mind.
That's fun. That's so cool. So let's see, I am a CDF fellow, I'm an AES member, I have 6 patents, 2 kids, guitars and saxophones, an airplane, a 1937 Morris 8 bizarre British car, an even more bizarre McLaren M8 replica built by a race car builder, bicycles, and many other toys. So I don't just do audio and video, I actually get out once in a while, and Jason and I were talking about being out this weekend. Boy, it was fun.
Oh, yeah.
All right, specifications list. A quick check, you're still hearing me and you're still seeing the screen, right?
Yep, everything sounds good, and the PowerPoint's clear as day. Thanks for checking.
Perfect. There's a pretty long list of things we could worry about, but I'm going to bring it down to things that really matter. And what's the right order? It kind of depends, but in the process of making your decisions about what to use, you should first be looking at the sound pressure level capability of a speaker. I remember you mentioning here a second ago that you're most impressed by those Sherwin Vega speakers when you were a kid because they were big and ballsy. Well, those things played loud. They still play loud, and so you need to first it's sort of like a triage. So that's French for saying you're going to the doctors and you don't know how long you're going to wait. You got to sort through. There's hundreds and hundreds of models of speakers out there, and I think the first thing you're going to need to look at is how loud do I got to play? How loud will this thing play? How loud does my client want it? And that's like the first level of sorting. Second level of sorting is, well, how good of a quality does this client expect? How much money can I throw at this stuff? And that's going to then affect the axial response to the sound power response. And the next thing you need to look at is, well, what directivity do I need to make the speaker work well for the application, both in terms of the index, like how much directivity it has, and what's the axis, where is it pointing? And then you can look at distortion, impedance, and profit margins. Smile, wink, wink, nudge, nudge.
Yes.
And so, quick pause. You can't make good money if you sell speakers that don't make profit. And if there's end user customers listening here, I have to say that the only way you're going to have a happy integrator that's going to take good care of you and stay alive to support your process is they got to make a profit margin, or else they're not in business. So you got to look at that. You got to pay attention to that, and that's why I mention it here. And it's not conspiracy theory. You got to make some money at this. So let's talk about the first thing, the sound pressure level capability. As a reminder, in the world of home cinema, we're not just working in vague opinions, but we are largely working against standards. There are standards for how a movie should look and how it should sound. And the best expression of those standards are either the film mix rooms or the screening rooms that are in the film studios out there. So this is a picture of one of the sound mix rooms at Skywalker Ranch. There's a division called Skywalker Sound. It's a beautiful room, is also a really good sounding room. It's built on the ISO 2969X standards or the SMPTE, Society of Motion Picture and Television Engineer 202M standards. And if you want to hear a movie, that's a great place to go listen to it. A mixed room is kind of like a movie theater, except that instead of a whole bunch of seats, there's a mixed console in the middle. And in a mixed room, the 3 speakers can play 105 dB per channel before they sound like they're just gonna fall out of the box. In fact, they
Yeah.
usually have a lot more headroom than that. There are surround arrays. Won't get into all that. There's many webinars we've done on that, but they typically can play up to 102 dB each. The immersive speakers along the top are designed to play 99 dB each, and the subwoofer system, the bass, is supposed to be able to play 115 dB. So in deciding what the sound pressure level capability of your system should be, it should match this if you want to hear with fidelity everything that the director intended for you to hear. Now, your client may not want it that loud because the total of all this is 120 dB.
Mm-hmm.
And I know 105 and 105 and 105 and 102, 109 doesn't add up to 120, actually adds up to a whole lot more. But the common aesthetic out there when mixers are pushing the levels and the faders in general, the peak level, this is not sustained, but these are like peaks, are
Right.
typically going to reach about 120 dB if you held up the sound pressure level meter in fast mode, and not much louder than that, because above that, it's just insane. Your client may not want that. So in deciding what is the SPL requirement, you need to know what's the theoretical need. You also need to know, how much octane is your client into?
Mm-hmm.
And they may never want to listen to over 95. And how do you find out? Well, what I like to do is to bring them to our showroom, play them a few little demos, then hand them the volume control, and then just go, well, set this where you want. And then I
Mm-hmm.
observe where the master volume setting on the surround processor, which is calibrated in decibels, where it lands. And some clients turn it up to +3, which is like, yikes. And most clients turn it down to -6 from reference, or sometimes -10. And then you know what your client's going to need in terms of SPL capability.
Anthony, I love that that's your method, because when we teach video, one of the main questions we ask the client is, where do you like to sit? And that helps us determine screen size. So as you said before, we're not just making this stuff up. It's a lot of it's based on standards and science, of course. And then also, what is the client into? I mean, they're the one paying the bill.
Right.
So I'm really glad that you guys use that method in audio too.
Yeah, it's really similar. I mean, ideally, video should cover 50 degrees of your field of vision. That's how
Sure.
screening rooms screens are set up.
Mm-hmm.
But there's people who like bigger and like
Right.
smaller, and there's a
Mm-hmm.
whole bunch of reasons for that, and you need to find that out. Now, as a reminder, I've got a whole bunch of slides here from the session called "How Loud is Loud Enough," and I'm just going to scooch through that super fast.
And
And please, if you want more data, go look at it on the site on the
yeah,
YouTube. Yep.
by the way, guys, the session that he's referring to and all of our previous sessions are on the AV Pro Edge YouTube channel. So feel free to go back and listen to those at your leisure.
Right. So as a reminder, in the distribution of all of the channels I just talked about, the center is definitely the loudest by at least 3 dB compared to the next ones down, which are the left and right speakers behind the screen, which are then again another 3 dB down, which is a 6 total from the center to the sides and then back. So in deciding how loud you need to play, if you have some budgetary constraints, just realize that if you got to put a lot of power and a lot of speaker, you need to put it in the center, and then you can start to have smaller things as you go off that center position.
Mm-hmm.
So the center channel dominates. You need more sound pressure level headroom there, better dispersion and coverage. It's got to cover all the audience because that's where most of the program material is. That's where you need the smoothest frequency response. And I'm sorry, no small low quality speakers are allowed. I hear sometimes people refer to the left and right speakers as the mains. They are not.
Right.
Maybe in music they are, but in a home cinema environment, the main speaker is the center.
Mm-hmm.
So front speakers, like I said, need to be able to play 105 dB in room throughout the bandwidth that they're playing. And in most cases, for lots of good reasons, you really only need a bandwidth from 80 hertz to 20 kilohertz. There's no need, and it's actually detrimental to have front speakers that play all the way down to 20 hertz. For more on that, go see the session called subwoofers. How many is enough? Was that it?
Something. How many do you need, or how many is enough? Yeah, something
Yeah.
along those lines. And we've determined after all these conversations about bass and placement and all these things that we need 4 subwoofers, and that's burned into my brain for the rest of my life.
Actually, I think the original paper from 2002 by Todd Welty on this to the Audio Engineering Society was subwoofers, how many is enough? So that's what's stuck in my mind.
Sure, sure.
Great paper, guys. If you actually want to learn a lot about that, go get the paper from the Audio Engineering Society website. You know, pay the $5 or whatever it takes to download it, or look at the distillate of it on the Harman International website. Anyway, so 80 hertz to 20K is all you need. So they're not really big speakers necessarily, and they need to play 105 dB if you don't want to blow them up. Or if your client is clearly in the, hey, I don't like it that loud, I like small screens, then maybe it's only 100, maybe it's only 95. Surround speakers need to play 102 throughout their bandwidth. And what does that mean? Let's quickly calculate it. So this is clearly covered ad nauseum in that other session on how loud is loud enough. But the thing you need to know is that given a stated sensitivity of a speaker, and that you will find in most manufacturers' spec sheets. I'm going to talk at the end. What do you find and what don't you find in manufacturers' spec sheets? And I'm going to lament that there's just not enough. But there was going to tell you the sensitivity. So if you know the sensitivity of the speaker, and if they actually reported it right, whatever that number is, to find out how loud that speaker is going to play for 1 watt at your seating position in a typical 3,000 cubic foot room, which is a 21 by 16 by 9 room. So not a very big room, kind of a smallish living room. You just subtract 7. Okay, so if a speaker has a stated sensitivity for 1 watt of 90 dB, the sound level you're going to hear at your seating position is 83. Okay, and
Sure.
if I had the time, which is probably about 3 hours, to explain exactly how that comes up, I'd love to do it. Maybe when we're all totally bored and have nothing else to do, I'll do a whole 3-hour session on how do you calculate that. Just trust me. Trust me. For a room twice the volume, 6,000 cubic feet, whatever is the stated sensitivity, the sound pressure level at the seating position is minus 10 of that. So if a speaker is described as 90 dB, you're going to get 80 dB at the seating position. And in a 9,000 cubic foot room, you subtract 13. So these numbers are really, really, really useful in figuring out how loud this thing will play, which is the equivalent of how fast will this car go if you give it, 300 horsepower.
Sure.
Now, these are values for 1 watt, the sensitivity. So then you go, well, the speaker can take 100 watts. 100 watts happens to be 20 dB louder. Long story again too, and how all the logs and logarithms and the price of gas in Latvia all add up into that. But if a speaker is a 90 dB speaker and it can take 100 watts, it means it's going to do 83 at the seating position for 1 watt, and it's going to do 20 dB more than that at the seating position. Whoops. For 100 watts. So 90 dB speaker will play 80 dB. I'm sorry, I'm losing myself. 90 dB speaker, 90 dB sensitivity will play 83 at the seating position. Add 20. What's 83 and 20? Anybody know?
103.
It's 103. So a 90 dB speaker that can take 100 watts in a 3,000 cubic foot room is going to play 103. Is that loud enough? Well, maybe for your client it is. It doesn't quite meet cinema spec, but loud enough. Now, if that speaker can actually take 200 watts without blowing up, you add 3 decibels to that, because doubling the power gives you 3 dB more. So now we're at 106. Okay. Now, this is all interesting. I'll get back over that. As a reminder, I've already gone through this before, and I will give you a few more slides in a real hurry. Now, the one thing I want to say, some people who are listening may go, oh, that's not the way I heard it in, whatever course I took on audio. I heard that, you double the distance and you lose 6 dB of energy, and that is true outside far away from any walls or anechoically. Inside a room, the rooms we're in are not anechoic. There are reflections. So there's some direct sound and there's some reflected sounds, and all those reflected sounds add energy back to your seating position that add back up energy compared to anechoic. So the thing to realize is that in a room, in a cinema, even a pretty good sized room, the rule of thumb is not 6 dB per doubling of distance. So whatever's the value at 1 meter, 3 feet, you don't take out 6 dB at 2 meters. You don't take out 12 dB at 4 meters. That only applies when there's no reflections. And we are in rooms with reflections, so it's a different number. That's partly explains why I have that number in the earlier slide. Now, here's this example I keep talking about, 90 dB speaker, which is a pretty typical, like a decent 3-way speaker, can usually do 90 dB at 1 watt. And let's put it in a 6,000 cubic foot room, which is 160 cubic meters. So that 90 dB in a 6,000 cubic foot room, you actually subtract 10 dB, which is 7 and another 3, which is you get 80 dB for 1 watt. 100 watts is going to give you 100 dB SPL at the seating position. 200 watts is going to give you 103. 400 watts is going to give you 106. So this is the point at which I go, you know what? If a client has a pretty big room, 6,000 cubic foot is about, I don't know, a room that's about 25, 26 feet long. And the speaker is a relatively typical 1-inch dome, 4-inch mid-range, 6.5 or 8-inch woofer with a 90 dB sensitivity. You're going to have to throw 400 watts at it to get the peak sound pressure level of a movie. And I don't know about you, but I'm never comfortable putting 400 watts into a regular hi-fi speaker with a 1-inch dome.
That's a lot of power. Yeah,
that's a lot of watts. There are some speakers that are made to take it, most won't. And so what you're going to end up with is if you have a client that tends to like octane and likes to turn the dial in the clockwise direction, you're probably going to end up with blown tweeters, blown mid-rangers, blown crossovers, just speakers that don't work well. So watch out, watch out, watch out. So now I do want to say that most speakers have the capacity to play 6 dB louder on short-term peaks, which is what a lot of program material is. So when a movie is peaking on loud scenes and there's 105 or 106 dB, the reality is the average level is more like 95 to 100. So that kind of matches what most speakers can do. And so what you ideally want to know is what's the long-term power capability of a speaker and what's the short-term capability of a speaker. And very few manufacturers ever tell you that. You have the tool now to calculate what that's going to mean, but you don't get the specs. So I'm going to talk about that a little later. I always like to acknowledge when people have done a good job. And a long time ago, the people at Genelec, they come out of the pro business, started to put on their spec sheets what was the short and long-term capabilities and described exactly what that means, how long the peaks are and stuff. So you could go from there. If you wanted to be super careful and conservative, you could design a system based on long-term capabilities so that no matter how the client's using them, they can't overload it. That's one way to do it. That could mean that you're going to be over designing the system for them. It may actually be a lot more power than they need. All right, so what do you notice? What don't you notice in terms of loudness and stuff like that? And this is again a rehash of the session from a few weeks ago. Just know that putting together a system that can play 120 dB total, it's just really loud. And again, if you haven't qualified that the client is a loud maniac, you may just not want to do that for them because you're going to be overselling them. So the other thing that happens is as you start to play loud, yeah, there are distortions. And the fact is that most people can't hear 1 or 2 or 3% distortion on program material. You can hear it on single tone, but you need to play that carefully. Don't over design systems to where you have enormous speakers that they're never going to use. So enough about that.
Anthony?
Yep.
I just wanted to ask you about something that I've heard over the years myself. There was a guy that was kind of a mentor to me in my early days of doing car audio, and he always said that you don't blow a speaker from too much power, you blow a speaker from too much distortion. Is that a fair statement? Oh, did we lose you?
That's yes and no, but that didn't work. I used can you hear me now?
Yeah, your camera came up for a second, but I lost your audio, but now I can hear you again. Yeah, you're back.
Am I back?
Yeah, you're back.
Yeah. I decided to see if I was back in business. It's funny, you know, the internet connection in this building's pretty fast.
I know it's
once in a while in these webinars, you just can't make it through.
Yeah, that's okay.
I can't explain. Well, I'm sure there's somebody sitting listening to this who's an internet
Yeah.
expert who can tell me all about it. Then please, send me an email because I need help.
Yes.
Um,
Yeah.
so the ultimately you can, if you put an amplifier that's big enough, you will overheat the coil of a woofer, mid-range, or tweeter, or the components inside a crossover, to which they burn out without ever clipping. So
Gotcha.
yes, you can do that. Now, when you do clip, when you actually have an amplifier that's too small, once you're clipping, you're actually increasing the duty cycle of the signal, which is like putting a lot more thermal energy into the woofers, mid-ranges, and tweeters. So it's a careful game. If you actually had a speaker that could take 100 watts and you gave it a 1 watt amplifier that was clipping all the time, it will be fine.
Got it.
Where it gets dangerous is when you have a speaker that's stated as 150 watts, and you put a 100 watt or 150 watt amplifier in it that you're overdriving because you actually needed 400 watts per the chart I showed before.
Right.
Then on the loud scenes, a fair amount of what's going to go into the speaker is clipped, it's distorted, and so then I was looking for a simple way to put it. It is basically, from a power point of view, not a sound pressure level, but from a power point of view, the coils on the speakers are just getting a lot more thermally heated, and you're going to blow them up.
Yep.
So, so it is, the funny thing is, if a speaker is defined as a 150 watt speaker, it's not a bad idea to give it a 300 watt amplifier so you never clip it, but be aware of what the limitations long term are going to be. So that's that thing that's up there, long term. And so if manufacturers would give you the long term capability and you could calculate it back and know whether or not in your system, imagine you have infinite power capability, that you have amplifiers that can do 10,000 watts.
Sure.
You just want to know where your speaker is going to get into trouble.
Right.
Now, speaking of that, the speaker measurement data that I like the best is the one according to AES 2-2012, if I remember right, which is a really smart statistical process. That's what's written there. So a bunch of really smart guys got together and looked at, hey, how do we define a test method that tells us really what the speaker can take? Right in the beginning of this, Jason, you said watts, and it's like, well, what do watts mean? Watts
What does
under
it
what
mean?
conditions?
Yeah. What
What
the
does
heck
it
does it
mean?
even mean?
Yeah, what does it even mean? What's RMS? What is it? Well, the work done by this group is really interesting. I think I've described this 2 or 3 times, but when they define a speaker's capability, whether it's an active or passive speaker, they place a certain shaped pink noise signal in the thing and gradually turn it up, gradually turn it up, gradually turn it up until they see a deviation in frequency response. And when the deviation is at 1 dB, then 2 dB, then 3 dB, that tells you something's going to go wrong. And the deviations could either come from an amplifier that's overloading in an active speaker, could come from a driver that's being pushed past its normal excursion, or it could come from power compression. Whatever it is, that's that point when you get to 3 dB of error in frequency response, that's telling you this thing's going to go bad. Don't use it up at that level.
Right.
And the better manufacturers out there are disclosing what that value is. And so telling you either in terms of volts or power or watt or sound pressure level what this thing can do before statistically, if you try to turn it up anymore, there's going to be a failure. And the AES2 scheme on most speaker designs tells us that if we try to turn up 1 or 2 dB louder than that limit point, that she don't go no more, Captain, there's a 90% chance of failure of some form. So be looking for that. So now's the point at which I start off my activism that I always do in these sessions, which is if the manufacturer doesn't tell you what the AES2 capability of a speaker is, pick up the phone, call them, ask to talk to engineering, and go, what's your AES2 sound pressure level capability, dude?
They're like, huh?
And if you're lucky, they go, I know exactly what that is. Thank you for
Right.
calling. I've been
Right.
waiting for somebody to call to ask me that. Or they're going to go, I'm going to have somebody in our PR department call you. Or like I always joke, they're going to call security on you.
Yeah, there you go.
Get out of here. Anyway, so a lot more on that, like, a whole 2 hours about that on how loud is loud enough. And then I want to get into other things. So the next thing I want to get into, which I've actually covered over the webinars a little bit here and there because it's a big passion of mine, is the frequency response and sound power response. Remember, I told you the story that I was going around with my dad, just like you were going with your dad, and came up, in front of a speaker. Gee, it would be funny if it was a Suro Vega too, by the way, because they
Yeah,
did do that at the time. A lot of manufacturers in the 70s would put
sure.
these frequency response charts printed right on the front face of the speaker. Um, so this matters a lot. This matters a lot for the next element of specification you need to be considering, which is how good does the speaker sound? So first thing we talked about is how loud does it play? And for some clients, that's all they care about. They're really
Hmm.
not, whatever. They don't really care how fine the sound is. And
Right.
for that guy put a bunch of Suro Vega speakers, he'll be fine.
Sure. No big
Um,
deal. Yeah.
no big deal. And then there's the next level, which is like we want to deliver not just loud, but finesse and quality
Right.
to our clients. So what really matters is what's called sound power. So smooth sound power to all the seats means that the direct frequency response, the sound going from the speaker to the listener, has a very even character, but also
Hmm.
that the off-axis response, which is what's not going to the listener, but bouncing around the room and eventually finding the listener's head, also have a smooth frequency response. So um, I'm going to drill into this quite a bit. I've done it before in these webinars. I'm going to do it again. Sound check. We're still okay. We're all good.
Everything's great. Thanks for checking in.
Excellent. So frequency response these days should be easy to get on Axis.
Right.
Damn, and whenever that date was that I was walking around with my dad, let's just say 1972 and 1973, somebody already claimed being able to do a speaker with a smooth response, and people had been doing that long before. Well,
Hmm.
there's still a lot of erring there, a lot of errors. And then the off-axis response, whether it's 40 degrees to the right or 20 degrees to the top, is still really pretty rough out there. And I'm going to show you why it's important to look at that. So smooth off-axis, smooth on-axis. So ideally what you want is a speaker that has a good on-axis response, which is shown here in green,
Hmm.
and a good off-axis response shown here in blue. It's not the same, but you don't want it to be too different.
Yeah.
So let's expand on that. So here's you in your 7-channel theater
Hmm.
with a speaker, center speaker, feeding direct sound to you. If it's a good speaker, the amplitude versus frequency response would be smooth. That's what's coming off the speaker. The
Right.
room's, of course, going to alter it, but what's in the direct field, directly from the speaker to you, as you change frequencies into as you put a voltage, an alternating current voltage, that sounds funny, alternating current
Mm.
voltage. A voltage with an alternating signal, up and down, AC, into the speaker at frequencies ranging from 30 or 35 hertz all the way up to 20 kilohertz without changing the voltage, just change the frequency. If you looked at what's coming off the speaker with a good analyzer, you should get this nice straight line. It
Right.
should be linear. That's on axis. And then off axis, you should get a nice straight line, and that's
Hmm.
a little hard to do. You can tolerate a little bumping, but this is what you're usually going to see in a reasonable speaker.
Still
And you
close
go,
to still
well,
pretty flat.
still pretty smooth.
Yeah.
And you go, well, who cares? Like, who cares what's going off over here to the door? Well,
Hmm.
here's why you care. Because in a room, this is the diagram that I keep showing over and over and
Oh yeah, this
over
is a good
again.
one.
You've seen this a
Oh
million
yeah, this is
times.
great.
So you get a direct sound, that's the blue line, and then you get a reflected sound, and that could be one that's missing your head by 10 degrees. It bounces around the room and eventually finds your head.
Hmm.
And then at 20 degrees, there's another bounce, it finds your head. And at 30 degrees, there's another bounce. This is off axis, 40, 50, 60, et cetera, et cetera, et cetera. So all of these reflections that bounce around the room can find your head after one bounce, two bounces, three bounces, whatever. 5, 6, 7 bounces. So ultimately, when you're sitting listening to a speaker in a room and you're whatever 12, 13, 14 feet away from it, I hope you're not right in front of the speaker. You're a little bit of a distance away. Um, the reality is there's a lot more of these red arrows than there is blue arrow.
Way
Yes,
more.
all the red ones are a little smaller, way more. And this is just a few selected ones. In reality, there's hundreds. They're all a little.
Ooh, Anthony, I think we may have lost you for a moment. Are you there? Ooh. Sorry, folks. We partially got him, but I think we may have lost him. Give me just a moment here. Anthony, if you can hear me, I think we lost your audio.
Than the direct sound, or very much quieter, but all together, when you add them all up, the reflection energy. I have been reestablished apparently.
Can you hear me? I think we lost you there for a good 10, 15 seconds.
I just went to get a coffee. No, I'm back. What was the last thing you heard?
You were starting to talk about the red arrows, and
Yeah.
we saw about half the room in red arrows, and then we lost you.
All right, I am back. And by the way, guys, I'm not on Wi-Fi. I'm actually connected to the
Yeah, you're
network. I
hardwired
can
now, which
see
is really weird.
I'm hardwired. I see blinky lights and everything, but whatever. Um, so one direct sound vector from the speaker to you, and then a whole bunch of reflected vectors that are all a little quieter than but between a little quieter and quite a bit quieter, but they all add up to a total energy that's louder going into your ear canal than the direct sound. So reflections do dominate. And because their total energy dominates, it's the quality of frequency response of those of those reflections that really matter. So you can have a speaker with a rough axial response, a direct sound that's not so flat, but if the sound power, the net energy going all the way around is smooth, it's going to sound good. And that's called sound power. That's the term in electroacoustics. Sound check, you can still hear me?
Yeah, you're back. Ever since you've come back, you're back nice and loud.
Nice and loud. I got my sound power back, man.
Your sound power, yeah.
Now, the way that's measured, this business of sound power, is the standard spinorama, as Dr. Floyd Toole likes to call it, which is a now standardized method, which is you put a speaker in a test chamber and you take 70 points around the speaker of measurement all the way around at 10, 20, 30, 40 degrees one direction, the other direction, the top, the bottom, and you end up with these 70 measurements. And with those 70 measurements, you look at different averages and groups of them, and you disclose that to the integrator out there. So you guys need this data to be able to decide whether this is a good speaker or not. So what matters? Which one of these measurements matter? Well, like, here I am saying almost professorially that this is what matters. Well, some people go, well, there's listener preferences. There's people who like it more this way or like it more that way. And, I like more bass, I like more treble, I like more of this. Is that true? Well, interestingly enough, Dr. Floyd Toole et al., uh, that's a term that they always use in papers to say that there's other people
Yeah.
involved. I'd like to know who this Al guy that's always hanging out with Floyd
He's
Toole.
everywhere, man. Guy's
He's
everywhere.
everywhere. Dr. Floyd and many of his acolytes have done exhaustive listening tests on people. So where they've put people in listening rooms, listening to all kinds of different speakers, and have established what correlation there is between people saying that sounds good and what the frequency measurements are. So don't trust me on this. Trust people who've spent their whole life doing it, who have doctorates in this stuff, and have proven over and over and over again that if you do this data acquisition and you show this result, people are going to go, this sounds good. So here's an interesting summary of years and years of his research. So first off, here's a case of 4 high-end speakers that range between $8,000 and $11,000 each, expensive things, and which have all gotten great rave reviews from the press. So here's speaker A, and here's a series of data points of speaker A, and a little bit later this explains it, but I'll mention this right here. The black line is the axial response, the direct sound from the speaker to the listener, that one blue arrow if you want. Notice
there's a
in
weird
this
dip, right?
particular speaker, there's a little dip
Yeah.
over here, but only in the axial direction. The green here is what's called the listening window. Man, I wish I could have my camera. I'm gonna take a chance. I'm gonna turn my camera on.
Yeah, I might as well give it a shot at this point. That's interesting too, in that black
Can you
one.
see
That's
me now?
black
You
screen.
can see
But
I froze. Look at that picture, man.
yeah, it's just black. That's so weird. But yeah, that weird that's so interesting that there's just one
Never
little
mind.
dip.
Never mind.
Oh yeah, just that one little dip right there at
So
about
that can actually come from a diffraction. Can you still hear me?
yeah, there you are. Yep.
Yep. That's 1,000, 2,000, 3,000, 3,500. That can simply be a little diffraction off the edge of the cabinet. And you move
Got it.
your head 6 inches to one side or the other and it's gone.
It goes away.
So
Yeah.
note that your 2 ears are 6 inches apart from each other, so they may not be even hearing that. Anyway, so the black line is the axial response. The green line is an average of the 0 degree, the direct in front of the speaker, 15 to the left, 15 to the right, 30 to the left, 30 to the right, and plus and minus 20 vertical. That's called a listening window. And that kind of forms an oval window in front of the speaker where people usually sit. The red line represents the reflected energy, which is the stuff that's not going to the listening window, but it's going everywhere else. So it's going to the walls, to the left wall, the right wall, the ceiling, and the floor. So that's everything past from 45 to 90 degrees, to the right, to the left, to the top, and the bottom. Sound check, you still there? Am I still here?
Oh yeah, you're good. Yep.
Okay. And then finally, the blue line is a really interesting one, which is a spherical average of everything going in all directions, also known as the sound power. So this is a speaker in which the frequency response fits. So this is a 5 decibel window. This particular thing from this point to that point is plus and minus 2 or 3 dB. That's a speaker that just from a frequency response measurement is a good speaker. The listening window looks almost like the axial response. That means that you can go all the way up to 45 degrees, 30 degrees in one direction, the other direction, top and bottom only 20, and the sound's not going to change very much from the direct on axis. The red line shows that what's going to the walls, other than this little bobble at 2 kilohertz that comes from the crossover region, is generally very similar to the axial response, 2 to 3 dB down. And then finally, the blue line is very similar to the axial response, turned down 5 dB without very big differences. This is a speaker that theoretically performs well, should sound good, theoretically.
It's interesting too that there's that same dip right around 2 kilohertz, and it's shaped about the same in all 3 lines, but it's actually, as we go from black to green to red to blue, it looks like the frequency in that dip is slightly lower on each line.
Yeah, that's probably a little idiosyncrasy of the measurement, but this dip in the axial response you will of course see in the listening window, because the axial response is 1 out of the 7 measurements that gets averaged in there. But you see in the green curve, it's only down 1 or 2 dB.
The one that I was spotting was the dip
you're talking about
before
this
that
one.
one.
Yeah,
Right there.
Yeah, absolutely. That's one that is worth worrying about. That's the crossover region. So that's right before the tweeter takes over.
Got
The
it.
woofers or mid ranges, I don't know what the speaker is. Floyd, this is actually a slide from a CEDIA presentation I've done that was originally from Floyd Tools courses, and it's a good speaker that was part of these tests.
Sure.
Maybe a speaker in the Harman line or not. But yeah, this is clearly a crossover deep region. So the woofer or mid range is beaming. It's probably a 6.5 inch woofer, 5 1/4, 6.5 inch woofer, and it's beaming a little bit so that when you're all the way off axis, there's a little less energy going there. Now it's really only 2 or 3 dB. It's not massive. There's speakers I'll show you later that have huge errors there.
Wow.
So,
okay, cool.
Speaker A, reasonably looking. Speaker B, another good looking speaker, reasonable frequency response on axis, little bobbles plus and minus 1 or 2. The listening window looks, the green one, the main window in front of the speaker, not just 0, but out plus and minus 15, 30 horizontally and plus and minus 20 vertically. Looks good. The reflected energy looks good. It's a little bit more weavy. And then the sound power does droop off a little bit on the top end. So not as good and stellar as that, but still pretty good.
Still pretty good, yeah, sure.
Still pretty good. Then we have Model X, which has an axial response that's plus and minus 2, so not bad. But that response is found everywhere and quite exaggerated over here in the off-axis energy region. And then we have Model Y, which has a pretty ugly frequency response, quite ugly frequency response on axis. And it's found all the way through. So the axial response is rough.
That's a
the
bumpy
listening window response, it's a bumpy road. The listening window response is actually quite attenuated. You're actually losing 3 or 4 dB through the listening window. So a speaker like this, you can't use in a theater where there's listeners that are out 30 degrees from the speaker, which is relatively typical for 4 or 5 seats. If you actually do the math and look at what a 30-degree angle is, it's not that wide. And so whatever, all 4 of these speakers were judged by members of the press to be good sounding speakers, but measure differently. So Now, take the brand away, take the speaker away, take the price of the speaker away, put it all behind a black grill cloth so that the listener can't tell what is actually being heard. And okay, I have a picture coming up in a second. So
Oh,
in a
sure.
blind listening test where you're just switching between speaker A, B, X, and Y, and in which this particular test is done in a chamber that's interesting in that the speaker is put on this platform scheme in which the speaker that you're listening to is put at a location. Then when you go to the next one, that speaker is quickly moved out of the way through this really sophisticated moving platform thing. And the new one you're listening to goes back exactly at the same place so
Right.
that you don't have variations in the room. And on that test, 350 listeners with a really big statistical value for that evaluated these 4 speakers and gave it a grade. And the winner was Model A. Next down is Model B, then Model X, and Model Y.
That's funny.
So some people did like Model Y. Some people liked the sound of the speaker. And, you know, there's a certain character to the speaker that enchants some people. But by and large, more people liked the better measuring speaker. So as a reminder, that was speaker model Y, the one with the rough response. X is the one with the sort of the less bumpy road, but still not smooth. B is this one that was pretty good. And then A was the one that was really good looking. So without any bias based on the look of the speaker, the shape of it, the cost, the price, the quality of the finish, any of that, just everything hidden behind scrim cloth, listeners tended to pick the speaker with the smoothest response group, not just the axial response, but also some off-axis responses. I'm going to show you that a little bit more. As, hey, I like the way this sounds better. So you may or may not believe that. You may be the type that likes this kind of sound, but when you're an integrator that is in the job of trying to satisfy more people more of the time, and in which you want the people, you know, your customers to be super happy, you may want to go towards something like this. Something where the disclosed value is a smoother response. So now, interestingly enough, in doing the statistics of this, you can actually correlate the frequency response and sound power and off-axis response to a rating value of with a correlation of 0.86. So this data tells you with a certainty of 86% what's going to be a speaker that sounds good. 1 would be perfect, as in if you had a correlation of 1, that meant that you had 100% certainty that everybody's going to like it, and what would happen, everybody would love that model and would hate all of the other ones. So it's not perfect, but if you're a speaker designer, or if you're picking a speaker for your client, you can have an 86% certainty of what you're giving them by just looking at these frequency response charts.
Interesting.
And when I say frequency response, I don't just mean the axial response, but I mean the spinorama values, the AES standard, the Audio Engineering Society standards. So Floyd says, no excuses for bad sounding speakers like this. So here's an $8,000 a pair speaker with this frequency response. Here's a $470 a pair speaker with this really rough frequency response.
Yeah, that's really rough.
Right. When you can make a vinyl wrapped box for $1,800 a pair that has this, or you can make for $200 a pair a little speaker that doesn't play very low, but if you added a subwoofer that has this frequency response. This $200 a pair, you know, add a $300 or $400 subwoofer, and you have a really, really good sounding system. One that on these listening tests, people will go, yeah, that thing sounds amazing.
It would score well, right? Yeah.
It would score well. So now, this is a speaker that sounds great. This is not a speaker my company makes. This is a hats off to a really well-designed speaker from the Harman Group that shows a bunch of really, really good data. Everybody that sees a speaker, hears a speaker, thinks it sounds amazing, whether it's professionals or consumers alike. And look at this. It has a very, very smooth axial response, a very smooth listening window. Note that the axial response actually goes rising up a little bit at the top so that the window is flat, because this is what matters more. A smooth reflected window. So this is called the early reflection. So the stuff that's going to the left and right wall, ceiling, and floor. And then a sound power that again is smooth. So it starts to have some directivity at around 2 to 250 hertz. and it goes to a directivity index, which I'll talk about in a few seconds, but that it's a smooth directivity index up until it gets to about 10 kilohertz, and then the sound power goes drooping off. The directivity index that's shown over here is essentially the inverse of this. In reality, it's this subtracted from that. So you see this blue line that shows you the directivity index that I'm going to talk about in a second. So now, so a little free propaganda. Grimani Systems was actually formed because of discussions around, well, a lot of different things around integration, but a big one was, hey, can we make a speaker with a better sound power, but is also audiophile and has a bunch of other benefits? And we developed and patented this waveguide called a conic section array, which is our secret sauce. And its main job is to have a wide and smooth horizontal dispersion so that the sound power of the speaker is really smooth. So seen from the top, this is the radiated energy out of the speaker. It's the same at all frequencies. It's very wide. You can go all the way up to 80 degrees off axis. So all the way over here, the sound's the same as on axis. And that gives us a consistent sound quality at all the seats, but also the direct sound and the room reflections are matched. You get the same sound coming directly at you from the speaker as the frequency balance of that sound bouncing off the wall once, twice, 3 times. So smoother sound quality, it is considered the holy grail. Not the conic section array, but the idea of having a really smooth sound power is the holy grail. We've just found a way to go find the holy grail without getting religious about this thing. So this is the spinorama curves of our biggest speaker called the Alpha. And here again in black, you see the reference response. So, you know, plus and minus little bobbles of 1 dB. In green is the listening window. Again, this oval window in front of the speaker, almost a straight overlay over the axial.
I was about to say it tracks almost identically to the reference point. That's crazy.
Yeah, because the waveguide basically sprays sound out at identical, all the way out horizontally and up to a certain place vertically. There is an intentional vertical focus, not really tight. It's plus and minus 30 degrees. So you go out to 30 degrees, vertically it sounds the same, and then it starts to intentionally fall off really evenly. So, and then this in yellow orange is the early reflections. So just like all of these other curves you saw earlier, it's, you know, it's essentially close to a carbon copy. It does rise back up a little bit at the high frequencies intentionally so that we can overcome the natural loss of high frequency that comes from the bounces off the room and air absorption. And then finally, the sound power, which is the blue, is basically take the listening window, copy it down 5 dB. There's a little bit of a bobble that comes from the vertical directivity of the pair of mid ranges, and there it is. And this is a speaker that, according to the spinorama standards, is going to sound good, and it does. So really, everybody that hears it goes, "Wow, that thing is amazing." Different speaker we make called the Tau has this series of curves. Again, good axial, good listening window, good sound power, all of the things that the AES standard says to do. Now, some manufacturers actually disclose this data as individual as these grouped curves, the spinorama averages, and some of them disclose the curves as individual values. And that can be kind of interesting because you can look into what makes those averages. This is our new Rixos S, which is a really compact speaker. It's about 4 inches deep. There's different versions, but about 18 inches tall and 12 inches wide. Plays really loud for its size. It's active 2-way. And these are the individual curves from 0 to 10 to 20, 30, 40, 50, 60, all the way to 90. So you can see that as you go off axis horizontally, the thing tracks really nicely. It just turns down evenly without any like serious dips or peaks or any of the stuff you see in other speakers. So now, some manufacturers disclose these things as curves, and some of them disclose them as polar plots, and that can be a little more challenging to look at if you don't know how to read that. This is a series of polar plots on our beta speaker, actually done not by us, but as at a professionally accredited measurement chamber in the Pacific Northwest of the US called NWAA. And it shows the polar response in dark is the horizontal, and in dotted line is the vertical. And we actually have an intentional bias. I'll talk about that later in the next section. But the horizontal, if you look at the 1 kilohertz and the 2 kilohertz, they're the same bubble. You look at 4 kilohertz, 8 kilohertz, the same bubble. So I'm switching slides between, this
You
is
can
1 and
barely
2,
tell.
this is 4 and 8.
Yeah.
Barely tell. You can tell that the verticals are intentionally getting focused intentionally.
Sure.
And then you get to 10 kilohertz and it's still very wide. Although interestingly enough, we do intentionally on the higher end speakers send a little more high frequency off axis than direct, so that again, by the time that high frequency energy bounces around the walls and gets sucked up by the air absorption in the walls, we've compensated by a little bit of emphasis, and it makes the speaker sound more open and wider and has some great effects. So, all right, now I'm going to take this whole discussion and drill down into one particular portion of that, which is the directivity. So just to summarize, we talked first about sound pressure level, how loud you want it to play before it blows up or sounds like it can't go no more. And
Right.
that's important. Second thing, overall sound quality, and that's frequency response and sound power. Third thing is how much focus does the speaker have into the room and where is the focus? And that's sort of it's a derivative of everything we just talked about. So directivity is an important thing, both in terms of its amount and the character of it. And again, because you hear more reflected sounds in a typical room, you need to understand how that sound is going to interact with the direct sound in the room, and you got to pay attention to it. But let's go back one step about what an electroacoustic device can and can't be. First of all, I'm going to describe the mythical pulsating sphere. It's not a speaker that exists, although there is a company called MBL out there that makes a speaker kind of
Oh
like
yeah.
this. It's
Oh
like a
yeah.
ball that pulsates in all directions.
Yep.
So if the speaker is well designed, it will have a flat axial response, which is the sound that goes from you to the listener, wherever the listener is, can have a smooth response. And it radiates evenly in all directions, which means the sound power will be completely flat.
Right.
So this is an idealized speaker. In reality, real speakers, not those MBLs, but real speakers, which are made out of cones and domes, will typically have a low frequency radiation that will be spherical, a mid frequency radiation that will be focusing forward, so hemispherical, and then a high frequency that tends to be quite forward biased. And that's a relatively typical thing you'll see, and you can find it in the directivity plots of speakers. The question is, how much of all of this do you want to make your room work? So what's all this about directivity? A real speaker with cones and domes, again, has a flat axial response, and its radiation, how it flows energy into the room at different frequencies changes. So those a typical 2 or 3 way cone and dome speaker will have a sound power that's generally tilted down, and that's because it starts to, as it beams forward, it's radiating less energy spherically, and so the sound power looks like this. The question is, how much of this can you tolerate? So here's another speaker. I haven't shown this one yet. This is a real speaker. The axial response in the spinorama is in black. In black, there it is. Good response. The radiation depends on frequency, and you can see that in the reflected energy that it's changing with frequency. So at low frequency, it's the same as the axial response. So what's going over to the walls is the same as what's going right to you. And as you go up in frequency, well, the walls are getting a little less, and then a little more, and then a little bit less. And generally the sound power of that speaker is tilted down. You see that?
Oh yeah.
So this is a real measurement done by the fine folks at Harman International on some undisclosed speaker. And, it kind of matches what I'm showing here. This has all been known for a long time. And overall, I don't want anybody watching this going, oh my God, this is horrible. No, actually, this is quite good.
Yeah, it's not bad.
It's not bad. And so the sound power really starts on the speaker, let's say around 1 or 1.5 kilohertz, and then it's, it falls off a little bit, so there's some directivity, and then it's smooth, and then above 10 kilohertz, it starts to fall off because the tweeter is beaming. That's just
Yeah, the
what it
tweeter
is.
can only do so much. Yeah.
Right. So how much do you want? So this speaker, I'm going to introduce a little notion here. I'm going to come back to it. The directivity of the speaker is actually the ratio between this blue line and the black line. How
Okay.
much is going directly to you versus radiating in all directions in the room. And I'm waving my hands around, literally, even though the camera's not on, nobody's watching me. I'm waving my hands around, like shaping the sound going in all directions, right?
I'm
And
imagining it right now. It's
you're
perfect.
imagining it, yeah.
Yeah.
So if you look at this, that blue line over here, compared to this black line, is about 8 or 10 dB away. This is 5 dB, and that's about 8 or 9 dB. And then if you look down here, what's plotted is actually the difference between these two lines. So in blue is what's called a directivity index. It starts at, there isn't actually a marker for 0, but this 50 line represents a 0. There's no directivity. It goes climbing, and somewhere around here, this value is around 7.5 or 8 dB up from that start point, okay? And then, so it's pretty smooth from about 2 kilohertz to 8 kilohertz, and then it goes rising.
Mhm.
Not bad, not bad. So is that what you want? So some speakers have more focus than others. You can get a focus by a stack of drivers. You can get a focus by a horn. You can get a focus by using ribbons. The
Mhm.
obvious thing you see out there is speakers with a horn, whether it's a 2 or
Right.
3-way. I've got this little graphic here. You know, thank you 3D rendering in PowerPoint. Um, whatever, 8 or 10-inch woofer, 12-inch woofer, and a horn. That's like the most classic way that we
Mhm.
see a speaker that has some intentional focus. So um, less obvious would be a speaker like this, which is the same as what I just showed, but with an extra woofer on the top. Nice thing about that is that that pair of woofers or mid-ranges introduces a directivity to a lower frequency in the vertical plane, so that actually could work better. But this, which is a relatively common array in speakers, you may not realize has a vertical directivity. The
Mhm.
pair of woofers are going to form a beam as of a certain frequency, and the pair of mid-ranges are going to form a beam as of a frequency. And maybe the trio of the mid-ranges and the tweeter, depending on how they arrange the crossover, is going to form a vertical lobe. So this does have a pattern control or more directivity than a regular woofer tweeter or woofer mid-range tweeter. This is what I
Mhm.
call a tapered array. And then there's this that you see out there from different manufacturers, stacks of woofers or mid-ranges and tweeters. And you may not realize, but this thing has a really severe vertical directivity pattern. It
Sure.
beams at you kind of as if the sound shelved above the tweeters and above the mid-ranges. So if you listen up here, there's essentially no sound in the mid-range and high frequencies. You have to be basically between here and here to hear the speaker.
Mhm.
So um, so what do you need? Well, you want to match the directivity to the room and to the intended usage. Know that a speaker with higher directivity that focuses more sound tends to have better clarity. The voice will be more intelligible. I said tends to, not always, but tends to have better clarity, and tends to provide a tighter imaging. So where sounds in a stereo soundstage are more easily located. Um, lower directivity that sprays more sound around has a smoother sound quality, a little less hard, and provides more envelopment. And so what do you need? What is the client like? So here's some general rules of thumb. So the traditional 2 or 3-way speaker has evolved over time as a good balance between directivity and spaciousness. It's just there's no secret. It has just worked out in most cases to be an easy thing to work with. But the fact is that in the world of 5.1 channel music or film, where you have a lot of speakers spraying sound into rooms, which rooms may actually be designed by designers and not have a lot of acoustical control, you can end up with what's called a cacophony, which is a kind of a big mess of sound in all directions where you can't actually tell any clarity. And in those rooms, it may be better to have some directivity. It may be.
Just a little, yeah.
Just a little bit. And if you're going to apply directivity, it's really important that it not be severely changing with frequency. Okay. Everything I just talked about sound power still is important here. You just have a higher directivity value, but you don't want the off-axis sound to change radically with frequency. You just want it to be a little tighter. What about in surrounds? Well, the 2-way speaker's okay, knowing that they tend to have a pretty wide dispersion up to about 3K. And then above that, they start to beam. So you're going to have the dominance or reflections, just like you do out of other speakers below 3 kilohertz, and above that they may beam. And in most surround speaker locations that are closer to you than front speakers, you know, in most rooms, you may sit 12 feet away from a front speaker, and you may sit 6 feet away from a surround speaker. It may you're now right at that dominance point where the direct sound can be disturbing. It can actually be distracting. And
Right.
so in some rooms, and depending on the sound format, it may be better to have speakers with a wider dispersion, something that sprays the sound out more, either using bipole type speakers like this that have drivers in multiple directions, or a speaker with waveguides like this is our Rixos S speaker. There's some good speakers from in the JBL synthesis line that have wide dispersion. There's a bunch of products with wide and constant dispersion that give a more immersive character because they're not drilling right down your ear, but also give a wider audience coverage. And I'm about to start talking about coverage in a second here, but you want to make sure that wherever that surround speaker is placed, it's not just driving into the people right in front of it, but it's spraying evenly to everybody forward and back from them. So what's all this about directivity? So let's look at the same speaker again. So flat axial response is important. Directivity index is something you should look at. This is the same speaker I had before. I should have waited until I had this graph up. If you draw a line through here in this upper mid-range, you can see the directivity index, which is the difference between the blue and the black line, is at around 8. And this speaker could be described as a speaker with a directivity index of 8. But it really isn't, because it's 8 only in a certain region, from 2 kilohertz to 8 kilohertz. At 1 kilohertz, the directivity index is more like, what do we got, 5, and then it goes drooping. So when you hear directivity index, you should actually be just told 2 things. What's the directivity index, and what's the region within which that directivity index holds? Or better yet, just look at a graph like this. If you don't have a graph like this from your on the propaganda from the manufacturer, what do?
Call them and ask.
Call them and ask.
Yeah.
Start a revolution.
Yeah, tweet them or something.
Just say directivity index matters.
Yeah.
So again, I'm bringing up this really excellent and rather expensive speaker. Flat axial response. There's the directivity index of this speaker. Note that for more money, you get a directivity index that starts. Let's just say that this starts at about 500 hertz. I mean, it's really smooth. Let's say from 750 to 8 kilohertz. So this is excellent,
really nice.
excellent.
Sure.
But that's a speaker that you can put in 12 different rooms, and it's going to sound good in all cases. Okay. It does have a rising directivity index at the high frequencies, so it's going to be beamy on the top octave. So you want to make sure you aim it at the listening position. It's not radical, you know. If you look at the if you look at the sound power, which is the spherical average all the way around, it does beam. If you look at the listening window or look at the reflection window, it's not bad at all. So this is our alpha speaker again under those same conditions. There's a directivity index. It's about 6. So if you take this, subtract there, and you look at the value, it's 5 or 6. And that's a kind of thing we like, is a hemispherical radiation. 6 is hemisphere. A sphere would be a directivity index of 0. 6 is a perfect hemisphere. If something's like a quarter in front, it's 12. So that kind of gives you a sense of how much it beams. So there's the axial response. There's a directivity index. All right. Now, in addition to the index of directivity, you also want to know, well, where's that pointing? Are you assuming that it's straight out of the speaker? Well, maybe not. Some speakers actually point down or point to the left, and you got to know what that is. So very classic thing, typical two-way speaker, woofer and tweeter, unless it's very carefully designed for it, will have a radiation pattern around the crossover that looks either like this, where there's a null pointing in this direction, or null pointing up, depending on the order and type of crossover. And you want to make sure that that speaker is actually aimed correctly at the listener. You'll have to tilt it down, or else the listener is going to be listening to a null here at 2 kilohertz, which is not what you want. So watch out for that. Now, how do you know?
Anthony, is it kind of a good general rule of thumb when when we talk about aiming speakers? I've always tried to aim the tweeter specifically. Is that a pretty good rule of thumb?
So what's interesting is the problem is not usually at the tweeter, the problem is at the crossover region. The tweeters have a broader dispersion than the interaction between the mid-range and tweeter or woofer and tweeter.
Got
So
it.
what matters more than the top octave, which does matter, I mean, you do want to make sure you're hearing all the way up, but generally this is more detrimental to the quality because it's right in the middle of voice range.
Sure.
So yeah, you do want to you do want to pay attention to this. Now, very few manufacturers are going to tell you where that null is. They're not going to give
Hmm.
you that data. So what do? Well, you either listen to it yourself by playing pink noise and standing up and sitting down and
Oh,
listening to
sure.
where that null is, or if you can get the curves in the spinorama form or individual curves, you can find out what that is. But generally, plan on most 2 or 3-way speakers, even if they're claiming to be wide dispersion, make sure they're aiming down and in. So that's what I say earlier. You basically want to, on the vertical plane, depending on how you think about this, well, depending on what you call the plane, but if you actually want to toe the speaker in, so point in
Right.
towards the listener, and wherever it is above or below the listening height, you want to aim it down or up. Now, that becomes particularly important with these things that are called Diapolito stacks, MTM, sometimes mid-tweet or mid,
Oh,
because
sure.
they have a lobing pattern that, as opposed to being just like this, is now symmetrical. So straight on, it's very good, but there's a very deep notch at maybe 15 or 20 this way or that way. So if you don't aim those speakers, you got a client that's listening to a cancellation around 1 or 2 kilohertz. That's a bad thing.
It's a bad spot for that to be too.
Yeah.
Too much
Now,
important sound right around
expanding
there.
on this, yeah, it's really critical. You do not want a hole in that region. For 1 to 3 kilohertz is really important for dialogue clarity and articulation. So now it gets more interesting. There in the new world of waveguides and horns, you can actually make a waveguide asymmetrical, where the sound is not designed to go straight out in front of it, but aim up or down. And there's a lot of reasons for that. There's a lot of cinema speakers that do that. And our new line called Rixos, this is our Rixos S, the speaker I talked about before,
Hmm.
is intentionally has a main listening axis of minus 12 to 15. And we do that so that you can put the speaker up a little bit higher at the screen,
Sure.
and without having to aim it down, it actually tilts down towards the listener. I'm moving my hands and pointing
Yeah.
my finger down. It's funny. So you do want to aim them, but in this case, you aim them not, as in you put them flat on this on the wall. And look at my little
Right.
animation, dude. This is a PowerPoint animation. You like that?
Hey, you man,
Um,
you're borderline a
so
graphic designer
uh,
now.
yeah, really not. Um, so how do you know what this thing was designed for? Well, hopefully the manufacturer is disclosing it. Uh, if they're not, you can ask. If they don't tell you, pink noise is your friend. Pink noise is your friend for a lot of this. Play pink noise on the speaker, measure it with a decent microphone
Yeah.
and an analyzer, or just listen to the pink noise. You'll be able to tell by you standing up, sitting down, where the main sound lobe is pointing to.
Anthony, this is like when we talk about in video with how important it is with an LCD panel to make sure it's aimed in the correct position. People insist on
Right,
putting them over the fireplace and stuff, and they wonder why
right,
the blacks are washed out, the colors washed out,
right.
because we talk so much about aiming. It's funny how similar that is.
Yep, it's exactly the same, and you want to be in the aiming pattern of it, or else you're missing really critical info. So,
Sure.
so this particular speaker, or everything in the Rixos line, is designed to be placed up a little higher than the listener, and it naturally points down. So
Hmm.
it's great for the side surrounds and back surrounds because they're normally quite a bit higher. But our main listening range is between 0 and minus 45. Intentionally. And there's other people doing that these days too. So find out what the listening axis is.
Hmm.
Now, you guys have all seen these horizontal center speakers with 2 woofers and a tweeter. That's
Yep.
the same speaker I had here, but turned on its side.
Right.
That's a problem. You take that speaker and you turn it on its side, and now you have these lobing patterns pointing at different listeners. So straight in front of the
Hmm.
speaker, it could sound fine. But if you move 1 seat to the left, you've got a giant hole at 1.5 or 2 kilohertz or 1 kilohertz, that's a bad thing to have happen to the quality of voice in a movie. Do not do that. And I know it's like a lot of people are like, well, but it's a center speaker. It's only a center speaker because they tell you it's a center speaker,
Yeah.
and you fell for it and you paid the money and you sold it to your client, and now they're complaining that they can't hear the dialogue.
Right.
Do not use those.
Or maybe they can hear it, but the significant other next to them can't.
Right. Exactly. What usually happens, I mentioned this in a session on one of these webinars, is the guy's usually going to sit here reclining, schlomping down. The
Yeah.
off axis is going to turn
Yeah.
the volume up until you overcome the lack of dialogue clarity, and then your partner is going to be sitting in front going,
Blasted.
I am getting blasted. I can't stand this. I'm going to go and make some cookies. I'm out of here.
Yeah.
And hopefully the cookies aren't laced with arsenic because they can't stand the thing anymore.
Yeah, right.
Oh, by the way, to be fair, there is a way to design a speaker like this. It looks just like this. It's actually what's called a 2.5 way,
Hmm.
in which at low
Oh yeah, we talked
frequency,
about this. Yeah.
we talked about this last time. At low frequency, the two speakers play together. As
Right.
of about 300 or 400 hertz, one of them drops off. The other
Hmm.
one continues up as a mid-range out to the tweeter, and then you have a little bit of a crossover lobe in the horizontal direction, but it works a lot better. Those cost more, they have lower sensitivity, they should be advertised as such. Or you look for a 3-way, which is 2 woofers, a mid-range, and a tweeter. They're more
Right.
expensive, they work a whole lot better.
Hmm.
Okay, other issues. We're only 20 minutes behind, so I'm feeling proud that I could do that. Woo!
No, that's okay. And guys, too, just to remind you too, if you have to drop off, it's no big deal. The session's being recorded, so if you can't stick around, totally understandable. We're gonna post it up on YouTube in the next day or so.
Yeah. Again, I was telling Jason that I was preparing this. We're trying to pare down the width of these topics week by week, and Jesus, how much can you talk about
I
specking a
know.
speaker?
It's
About 5 hours.
yeah. I
Um,
mean, it's yeah.
so I'm bringing it down to probably what will be an hour and a half, and by the time we're all done, and I really appreciate your guys giving me an
Oh, yeah.
extra half hour of your time.
And,
That's
and
really cool.
Anthony, it's no different than, if a friend or family member calls me up and says, "Hey, I'm looking to buy a new TV. What should I buy?" And I go, "How much time do you have to talk right now?" It's not as simple as just saying, "Oh yeah, just go buy the X, Y, or Z." You have to ask questions. You have to know the room. You have to know what the person's into, what their preferences might be. I mean, it's a
Right.
whole big deal.
Right. Absolutely.
Yeah.
So next issue, what I'm going to do next is go through a bunch of issues kind of in rapid fire. The next issue is distortion. This used to be a
Yes.
really big deal years ago.
Yes.
And these days, I almost don't want to talk about it because even at a very moderate price, drivers have really low distortion.
Hmm.
I mean, I've picked up a fair number of $200 and $300 speakers that have distortion that's under 1%, which means it's not audible. But
Right.
caveat emptor, that means distortion analyzer beware. It does depend on the harmonic of the distortion. So
Yes.
1% of second harmonic, which means that if you're playing 1 kilohertz, the distortion's at 2 kilohertz, is
Hmm.
hardly audible. It's actually, I'm going to say, is not audible. But if it's a fourth harmonic, which is 4,000 hertz, if you're playing
Right.
1,000 hertz, you will hear 1% because it's far away enough that you're actually going to distinguish it. So what
Is
you need,
is that always separated by 4, or is that just a number you picked out?
so fourth harmonic means it's 4 times higher,
Right.
right?
But
So
and that's going to be way worse than, say, a third harmonic or a second, sounds like.
the closer the harmonic, the less
The
audible it is
less. Yep, got it, got
because
it,
your
got it,
auditory system masks it.
got it.
So most manufacturers only disclose a THD, total harmonic
Yes,
distortion, without telling you what the content is. And
right.
ideally, what you want is all of that. So, so it depends on the content. In some cases, a distortion that is measured in a speaker is actually not harmonic distortion, but it's noises, buzzes, and other crap that's going on that shows
Hmm.
up as distortion. So let's take a look at that. So here's a measurement on a speaker I just calibrated a week and a half ago.
Hmm.
So this is a raw response of the speaker at the seating position, uh, reasonably good speaker. And this is the distortion as THD. The black line is total harmonic distortion.
Hmm.
When the average level is 70 over here, the distortion value is 10, 20, 30, 40 dB down, this is 1%.
Right.
1% is 40 dB down. Now, that's in the mid-range. This particular speaker, the distortion, the THD rises up to 3%, which is 30 dB down. So, oh, actually, I'm sorry, the overall response rises up too. So let's look at that again. So if we take, this is the average value here, 10, 20, 30, ignore this peak, so 30 to 35 dB down. So the distortion does go up to 2 or 3%. Do you hear it? Probably not that much. This is troubling. The fact that there's a little peak and a little peak. What's going on? Well, it turns out that the speaker had a little buzz, like at a certain frequency, in this case around 150 hertz. As you sweep up and down, you would hear, like there's a little place where either the cabinet or the drivers were buzzing. So it's not distortion in the harmonic sense, but it's actually distortion in that it's a sound you don't want to be hearing. So now let's drill down.
I'm sorry, I was just going to say that that really sparked something that I experienced personally many years ago. We had somebody, it was actually in the car audio days, somebody came in and was just having this massive buzzing problem with one of the speakers. And I think what you're getting at here with this particular case is kind of similar to what I saw. It wasn't necessarily something in the electronic signal. In my case, when we took the speaker out of the cabinet, one of the tinsel leads was bumping up against the cone. It was either manufacturer error or something, but it wasn't necessarily an electronic problem. It was a physical problem. And I think that's what you're getting at with the cabinets and stuff, right?
Exactly. So in in speaker tech, or speaker specs or speaker measuring, those are qualified not as distortion but as buzzes and other mechanical effects.
Buzzes and other,
Buzzes
and others,
other. So all of that kind of gets lumped together into bad quality sound. So this is the THD of that speaker. This is the second harmonic of that speaker. So this is all measurement with Room EQ, all measurements with Room EQ Wizard. You can get this, you can download it free. Please give the guy who created the program 50, 100 bucks of a donation, because he's really good at it. But note that the content of the distortion here and all the way down through here is clearly second harmonic, and is not going to be very audible because it's a very close frequency. The second harmonics means that when you're playing 300 hertz, the distortion product, the main thing that's showing up is 600 hertz, and it's 10, 20, 30 dB down. You're not going to hear it.
It's going to be too quiet for you to hear,
But look over here. The second harmonic has no content here. This is something different, okay? So let's look at the third harmonic. So in the third harmonic, notice that as we're going up in the harmonic, the third harmonic is quieter. And it's another 5 or 6 dB down, which means it's going to be less audible. But in the third harmonic, we're starting to see some of this crap show up. And then here I have the fourth, fifth, and sixth harmonic. These are all much lower. So as distortion goes, which is little tweets that are replicas of the original sound multiplied up in frequency, they're all really low. But this is showing up. And then if I look at the 7th, 8th, and 9th harmonic, these are all really quiet. They're like another 15 dB down. So from a straight distortion point of view, harmonic, the speaker has no trouble, okay, at the 2nd, 3rd, 4th. But it does have a...
Oop, Anthony, I think we may have lost you.
A buzzing problem in the actual construction or design of the speaker. Can you hear me now? Can you hear me now? Can you hear me now?
We lost you for about 5 seconds, but you're back now.
All right, am I back?
Yep, you're good.
All right, cool. So this data, some manufacturers disclose, but good news is you can measure this yourself. Get a basic test microphone from Parts Express, 70 to 80 bucks, and go out there and get the speakers you like to use and measure these things. You can measure them at 2 meters, 3 meters, doesn't really matter. It's going to tell you what's going on. And so this is really cool info. So that's distortion. By and large, again, most speakers today have a distortion that's low enough that you don't need to worry about it too much. Next thing is impedance. Now, you look at the specs of an impedance, and they're going to say, hey, this speaker is an 8 ohm speaker, but know that in generally that just means it's an average. It's an average over different frequencies. And I'll show you a frequency curve in a second. There's also a rule by the FTC that says that, the Fair Trade Commission, says that if you're going to disclaim 8 ohms, you're not allowed for the impedance of the speaker to be any lower than 20% below that, which is 6.4 ohms.
That's good.
And I've seen plenty of speakers that say 8 ohms that go down to 3 ohms. That's a big problem.
Yep.
So the actual real resistance of the speaker goes up and down with frequency. It's called impedance because it's a net value in the real imaginary terms of the math of it. But you can look at the resistance at different frequencies. Overall, you want to make sure that your amplifier can drive it, and in many cases, it's about the protection circuits of an amp. So most modern amps can drive a 2 or 3 ohm load, no trouble at all. But most modern amps have an internal protection mechanism designed by the engineer who's built the amp to self-protect. Because if it sees something around 2 ohms, that's getting close to too much current or too
Oh yeah.
close to a short circuit, and the amplifier may shut down. Even though it's not going to self-destruct, it's going to go, something's not right. And it's going to shut down when your client has had a few friends over, all of
Yeah.
which have tasted a little single malt scotch, and now
Yep.
they're
And
watching a movie
they're
or they're
blasting
watching
it.
a
Yeah.
game and they're blasting it, and that's when the system's going to go into protection. And some amplifiers go into protection by just limiting. They just don't play any louder, which is nice. They don't do anything else but just not go into clip. Some of
Sure.
them just shut down completely and don't
Oh yeah.
come back up until you flip the power switch. So now your client who wants to show off to his buddies that he's really badass, he's high octane, he's got really good, Scotch whiskey. Now he's sitting with his buddies that a second ago were going, ooh, 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 and now it's all quiet.
Yeah.
Guess who's not happy?
Yeah. It could. They're probably embarrassed, which is not good.
They are, the term is they're pissed.
Yeah.
And guess who's going to get a phone call at 10:30 at night on
Oh yeah.
Saturday? When
I
you're, quietly at home reading a book because, you're so tired of this music thing by the time you get home and you're getting calls like, and like, whoa, whoa,
oh yeah.
whoa, who are you? Calm down.
Right.
So here's the deal. Here's an impedance curve on a relatively typical speaker. This is actually a ported speaker that shows a curve going up and down and up and down and up and down. This is a real
Hmm.
measurement. The average could be drawn somewhere here at around 5.5 ohms.
Right.
Okay. And that average is just the average of what's here and here and here and here and here. And the minimum is 3.5 ohms. Not too bad. Not too bad. This comes from the resonance of the woofer. This is the resonance of the port of the speaker. And
Hmm.
then the impedance goes down. Impedance goes down means that the system is less efficient over here. And
Right.
then the impedance goes up. This is a resonance of maybe the tweeter system or this is the rising impedance of the woofer. Crossover, tweeter resonance, and then it goes back up. Okay, not an uncommon chart, but it does show, by the way, that the impedance goes from 3.5 ohms to 22 ohms.
Yeah.
So what's the real number? Well, the real number is the average.
Hmm.
So this isn't bad. But I have seen speakers, again, they go from 30 to 3,
Yeah.
and are described as an 8 ohm speaker.
Mm.
Or I've seen speakers that go from 20 to 2 and are described as a 4 ohm speaker. And that particular speaker played at a high sound pressure level in an amplifier that's built very conservatively to protect when there's too much current going out, is going to result in dead air right when you don't want it.
Hmm.
So be looking for that. Now, I challenge most of you to find an impedance curve on most speakers made by manufacturers in the CEDIA channel.
So, Anthony, I'll tell you, I've been following speaker manufacturers and drooling over speaker specs for more than a third of my life. I've never seen an average impedance graph like this, not once.
Right. So I got news for you. If you get out of the residential and car audio business and go into the commercial side, they actually give it to you. Why?
Oh,
Because in that business, if you
it's way more
screw up,
important, right?
there's hell to pay. In some
Yeah.
cases, safety, security, lives are at risk, and so they give you that data so you don't misdesign the project. So.
Oops, Anthony, I think we may have lost you for a second. Can you hear me?
If you want to know the
Oh,
impedance and you don't have it,
there you go.
what do you do?
Sorry, Anthony, I lost you for about
I
5 seconds there.
can.
Sorry.
Okay.
There you
So,
go.
right. So if you want to hear, if you want a measurement of the impedance and it's not in the propaganda from the manufacturer, what do?
Call them, tweet them, email them,
Call
get a
them,
hold of them somehow.
tweet them,
Yeah.
tweet them. pick up the phone, email them, talk to the rep, talk to everybody, and go, I need the impedance curve on this. And I go, why do you need that? The margin's 62 points. No, I want the impedance curve. I want to make sure I'm designing something that my amplifier is not going to shut down. Now, then you
Sure.
need to find out what the amplifier manufacturers is designed for. Call the amplifier manufacturer. Go, at what impedance do you start shutting down? And if you do all that, you won't have angry clients, and you'll get to read your book on Saturday night while you're sipping a really nice cognac.
There you go.
Right. All right. Next thing, active or passive? Well, very simply, I know this is a very broad spec, but active speakers are a way better way to go today. They're way more efficient. You get a lot more out of the power of the amplifiers than what you dissipate through the passive crossover. You get a much higher quality potential. A lot of the speakers in those charts that I showed you had really smooth frequency response. Those were all active speakers in which the crossover was implemented either out of analog devices or preferably digital crossovers where you can really tweak the thing. There's less guesswork for you. And the benefit of having a digital crossover that has protection and can actually be addressed through internet protocol is that you can control it from your computer. When you go on site, you can monitor it by remote when you're back home, and you can end up with a way more efficient, more precise, more flexible, better sounding system. And some digital active speakers also give you a room EQ correction built right into the speaker. All of our speakers do that, and some other manufacturers do that too. And then you can custom tailor the speaker to the room or to the listener, and that's the right way to go. At this point in the industry, the way I look at it is everybody should be doing this, and not enough people are doing it. You should be as an integrator, you should be looking for those. Whether this is actually built into the cabinet of the speaker or a dedicated rack mount amplifier system that's made for that speaker, doesn't really matter. It's just dedicated thing. It's just way better way
I'll
to
just
go.
tell you from my experience, I'd say in the last 10 years or so, I've seen
All right.
way more active speakers start to pop up.
Right. Certainly in the pro audio recording studio business, it's the standard.
Totally,
It's
yeah.
still not very common yet in the consumer space. So again, all of our speakers are active, digital crossover, monitorable, all the stuff you should be doing. So,
Sure.
okay, now some conclusions. Without pointing any fingers at any particular manufacturers, I mentioned earlier a few times businesses of, hey, did you get this data on the spec sheets? Well, here's a spec sheet for a residential speaker from a well-known manufacturer in our space that tells you for these three different products, it's a two-way speaker. It's got a 1-inch pivoting silk dome, a 6.5-inch woofer. Yeah, I could tell by looking at this. I didn't need that. It's got a rubber surround. Yeah, okay. This one has a filleted rubber surround. It's 8 ohms. Where? It's 92 dB, 1 watt, 1 meter. So is that 1 watt, 2.8 volts, or 1 watt relative to the impedance? I'm not really sure.
Not sure, yeah.
There's no frequency adjustments here. There's a little bit of a tuning. The frequency response is 40 hertz at 20 kilohertz plus and minus 2 dB. Okay. It can take 100 watts undistorted. Well, but does that mean it can take it forever or just play it
For how
without
long,
distorting? For how long?
yeah.
And here's its dimensions. Anyway, that's what you get in most of those manufacturers. Now, check it out. The same manufacturer on the commercial side, this suddenly, for one, the sensitivity goes from 92 dB to 88. Interesting. The frequency response is disclosed here in two different ways. It shows you the 3 dB point and the 10 dB point. And look at that. It's a wider window.
Right.
Power capability, 50 watts continuous pink noise. Not just what it can take without distorting, but if you play the speaker and put it at 50 watts, it will play it all day without blowing up. Okay, that's what I want to know as a commercial manufacturer. Here it's giving you the coverage angle. So it's not giving you the directivity index or any of that stuff on this one, but it's just giving you, hey, this has a cone of 130 degrees total. So plus and minus 65. And check it out. There's a directivity index of 4.85 between 500 hertz and 16 kilohertz, which is also a Q factor. I'm not going to go into that. So these two correlate to each other through math, but Why is this not here? This is the Resi speaker. Why is this not here? That's the commercial speaker. Why is it here? It's the same manufacturer. Pick up the phone, call the engineer. It's the same engineer. Ask him for the data.
Yeah.
But wait, there's more.
There's
Here's the
more.
manufacturer. All of you guys recognize what this brand is. But hats off. On that same commercial speaker, they give you all the potencies, vertical and horizontal. They give you a frequency response plot, SPL versus frequency, and an impedance curve. Check it out. It's right
Oh,
here.
cool. Yeah.
An actual impedance curve. And then they give you the not just the frequency response, but the frequency response at different angles. It's impossible to see this, sorry guys. But there's an axial, a 15 and a 30-degree response that actually shows you what you need to know in terms of coverage. They have the data, they're just not giving it to you.
Right. Yeah, the
And
information's out there.
it's not because they don't want to give it to you. It's out there. It's not because they don't want to give it to you. It's just marketing goes, no, we don't need this. So
Right.
another manufacturer making actually a very superb flush mount speaker, 12-inch coax, lots of data. You can't even read it. Lots of really good stuff in here. And then a lot of curves, beam width, directivity index, frequency response at different angles, impedance curves, it's all here. So this data is available. It's incumbent on you to go get it. Now, little spoiler alert. Been working out of frustration of all of this. I've been working within a committee within CDF that's been formed a few years back now. That's called the Designer Facts Committee, in which we're wanting to standardize how this is disclosed and
Great.
encourage manufacturers to give this stuff. This is this is how it would be disclosed. There's 2 pages, and this is a fake speaker called the Laut speaker. It's made in Germany, yeah. And whatever, the numbers are random in here, but this is a speaker that's supposed to be able to play 115 dB at 1 meter,
Right.
all day long. And there's a little bar over here that shows you that number. And within that range, this is not telling you anything about the quality. That just goes, this is what this thing can do. Other speakers can play 125, others can do 105, depending on what your client needs or how big the room is. You need that or you don't need that. It's also telling you, depending on the room size, what it can do. So 115 at 1 meter means you can play 108 in a 3,000 cubic foot room at the seating position. That's a 7 dB difference. Or 105 in a 6,000 cubic foot room, or 102 in a 9,000 cubic foot room. This is incredibly useful because without having to do any math, you go, okay, so I'm working with a client, I got a 6,000 cubic foot room. If I choose a speaker, I can play 105 dB all day long without breaking. Cool, I'm done. And by the way, on short term, this particular speaker can play 118. It goes 3 dB higher. So if that client, likes it loud, they can play 108 dB peaks. Cool. And then there's a recommendation, which is this speaker, if you want to play reference level movies, this speaker would work well for rooms up to 6,000 cubic feet. Recommended for that. If your client doesn't like it so loud, or if the room is smaller, you can do different things, but that's all helping to guide. Then there's a description of what this thing is made of. By the way, this particular speaker, it features componentry made in the mountains of the Netherlands.
Oh, nice.
Yeah. If anybody knows the Netherlands, it's below the level of the ocean and it's flat.
It's like the mountains here in Florida.
Yeah, exactly. It's high altitude there. And then there's a whole bunch of frequency response data, a little bit like a little bit like it was in the commercial side of the speaker craft thing, showing you what the ranges are for different windows. And then there's a frequency response accuracy, like what is the axial and listening window and all of that. Then there's a directivity index at different octaves. So that particular mythical speaker has no directivity at 125. It climbs up to 5, 5, 5, and then 6. And then it tells you the directivity index in the crossover region. So right in the crossover, the speaker could have a directivity of 7. It shows you the coverage. It shows you the sensitivity, the power handling, the voltage capability, the impedance. Somewhere in here, it shows you the listening axis. I think I bypassed that. I forget where it is, somewhere in there. And the connector type, a bunch of different things. Interesting thing is also tells you, given the impedance of the speaker, what the wire length gauge you can get away with is.
Right.
So you ask most people, well, should you use 12 gauge, 14 gauge, 16 gauge? And people go, oh, you should always use 12 gauge. It sounds better. It's like, well, if you've got 3 feet of distance between the amp and the speaker, there's no audible difference between 18 gauge and 12 gauge. And I know that sounds like complete heresy. And I would challenge you to a blind listening test. If the
Sure.
wire's short enough, there's no resistance to it.
Right.
And this is helping the guy to figure out, well, just how much copper do you need for this particular speaker. Next page would be a bunch of curves that give you all the stuff you need to know, the impedance curve, the axial responses, blah, 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 all the stuff we talked about. So that's coming to a speaker manufacturer near you. Just be on the lookout for it. All right.
Fingers crossed. That's awesome.
Fingers crossed. So what to look for in speakers: good response in the passband, good off-axis response, good dispersion, no big lobes, the right directivity for your project, the right power handling for your project, the right efficiency, and those two together give you sound pressure level. I didn't talk so much about this. I kind of ran out of time a little bit. I did extend into that in the session on how loud is loud enough, but you want to make sure that the speaker can play bass loud enough. So a lot of manufacturers say, hey, my speaker plays down to 60 hertz or 40 hertz. Yeah, but does it play it loud without farting?
Right.
So you got to make sure it can do that. And ultimately, you want it to be reliable. So let's talk about that for 2 seconds. What is reliability? Generally, I can pretty much attest that if you're keep the speaker within its power handling capability and don't spray water at it for speakers that are not waterproof, it'll generally be reliable.
Sure.
And once in a while, without you doing anything wrong, a solder joint may fall apart inside, a driver may open circuit, and you didn't abuse it. It was just a manufacturer defect. But by and large, you don't see a lot of those anymore. Years ago you did, but these things are built really well today. If you overdrive it, reliability is going to go down. So just try to stay within that power handling region.
Anthony,
right?
I'll tell you, I've got a pair of speakers I've had since the late 90s, and I had the drivers refoamed about 10 years ago, and that's the only work I've ever done to them. They've been great, but I also haven't played them to death either. I've played them responsibly.
Right. And they can last a long time. There's no reason they couldn't. I do see things happen sometimes with the ferrofluids, which is a cooling fluid put into drivers. Sometimes those harden. They actually start to dry out and harden and like screw things up. So without abusing the speaker, they can start to drift, but there it is. Okay. You can read a lot more about this stuff by reading through all these different materials. Again, I'm always promoting Floyd Tool's excellent book on this stuff, but there's a bunch of good info out there on acoustics and speakers. If you need to reach me, here's my contact info. I would say if you have a question, it is I'm going to ask you to just email it to Jason so that everybody can read it. I will then get them an answer and everybody gets the answer. That's a cool way to do it. If you're feeling like your question is very, very, what's the word? Very confidential or something. Hey, don't get personal here, but it's something that's on a project that only you need to know about. You're welcome to email me at this address.
Yeah, guys, and feel free to email me if you'd like to. It's jason@avproglobal.com. Feel free to email me anytime. And it looks like, Anthony, there's 3 websites. Yep, good.
There's some propaganda. I talked again for an hour and 45 minutes. Like, where does the time go? Oh my goodness. And I don't know if there were any questions as I was talking. Did anything pop up from the audience?
Anthony, I had the question box open the whole entire time today, and nothing really came in. Everybody was sounds like everybody was just kind of listening in. So no questions as of now. But if you guys do, again, feel free, email me, jason@avproglobal.com. I'll field those questions up to Anthony, and then everybody will have the answer because more than one of you probably have the same question. So I think that's the easiest way to do it. We'll definitely do that. Anthony, man, thank you so much. And another great session. For those of you who are listening, we had this whole entire audio expert series. We've been doing them since, gosh, I feel like March or so, or maybe April. We've done tons of these, and we're getting down to our, and we're getting down to our last few episodes here. So next week, for the next 3 Mondays, we're going to be live just like we were today. Next week, we're going to talk about acoustics. And then we have the week following, we're going to talk about the sweet spot in the home theater system, where you should sit, things like that. And then the very last one will be sometime in July, and then that'll be it for the audio expert series. And again, guys, for any sessions that you may have missed before, these are all on YouTube. So if you want to go back and catch up or re-listen or re-watch, feel free to do that at your leisure. Guys, those are all up to date on the YouTube channel. Oh, cool. There's Anthony, and he brought his camera up, so I think that means his audio is going to die.
Yeah. So thank you guys a lot. Oh, I tried to turn my video on again.
That's okay. That's okay.
All right.
That's
Can you
so
hear me
cool.
again?
Yeah, you're back. Yeah.
This is ridiculous. All right. So I want to thank you guys for listening. I want to thank you guys for listening. And I again want to thank the guys at AV Pro for putting these things on. Realize that all of the things we're talking about here have nothing to do with the products that they sell. And so this is purely altruistic. You know, hats off to those guys. Buy a lot of their stuff that, of course, has nothing to do with any of the speaker specifications, but buy a lot of their other stuff, because they are good people. They really do care. They are responsible, and they'll show that they'll put stuff on like this just for the sake of the industry. So
yeah, guys,
just hats off.
We're CDM members. We're all about the education. You know, we have this philosophy that you know, the more people that are smart about this stuff, the better the installs get, and the whole industry just gets better with more education. So thank you for the kind words, Anthony. Thank you again for the presentation today. And if you guys do have any questions, feel free to reach out. With that being said, enjoy the rest of your day, and everybody have a great week. And we'll see you same time, same place next Monday. Thanks again, Anthony.
All right. Thank you.